Alright, hello class and welcome to the third section of the series of our classes for CSC 321 Advanced Level Programming Language C++. Today we are going to talk on variables. What are these variables? How do you declare variables? What are the rules governing use of variable and some other things related to variables such as constants, strings, and other things. Okay, what is a variable? A variable is a portion of a computer memory that stores a value. A variable needs a name that identifies and distinguishes it. Variable name can be R, Y, X, etc. The variable can be any name with the exception of C++ keywords. It can be any name as long as it does not belong to the C++ reserved words such as the int, main, cout. What we mean by C++ keyword are all the reserved weights that are meant to be used by the C++ language. All the weights that are reserved to be used by C++ language cannot be used as part of the variable name. Okay, should take note of that. So, a C++ identifier is a name used to identify a variable, function, class, module, and other user-defined item. Okay. Now, let's look at what are the valid rules. What are the rules governing how we declare a valid identifier? We have some number of rules that you need to follow as long as you want to declare a valid identifier or a variable. Okay. One of the rules is that the sequence of one or more letters, digits, or underscore characters. A variable must contain sequence of one or more letters, digits, or underscore characters. Just a single letter is okay, maybe an A, or it can be or it can be more than a letter. That's as it's indicated here, one or more letters. What do you mean by letters? A to Z, either in uppercase or lowercase, and it may have some digits, 0 to 9, and it may have an underscore character. Okay. Second one, spaces, punctuation marks, and symbols cannot be part of an identifier. We don't separate them with space, and we don't include punctuation marks such as question mark, comma, semicolon, inverted comma, and what have you. We don't include them when you are naming an identifier. And of course, symbols, any symbol that you know on your computer, we don't use it as part of an identifier. Then the third one, identifier shall always begin with a letter. It's a must, compulsory. You should know that when you want to write the name of identifier, it must start with a letter. Perhaps identifiers can also begin with an underline with an underscore character, but such identifiers are in most cases considered reserved for compiler-specific keywords or external identifiers. In some cases, you may start naming a variable or an identifier with an underscore character. Yeah. In most cases, it's considered as external identifier. Okay. Then the fifth one, identifiers can be containing two successive underscore characters anywhere. Wow. They may be having two successive underscore characters anyway, maybe at the beginning of the variable name, at the middle of the variable name, or at the end. You can have underscore. It can be single, it can be double. Okay. Then the sixth one, in no case can identifier begin with a digit. What are we saying? An identifier can never begin with a number. Okay. And the last one, the C++ language is a case-sensitive language. Yeah. Okay. That means that an identifier written in capital letters is not equivalent to another one with the same name but written in small letters. For example, the result variable in capital letters is not the same as the result variable or result variable in small letters or in title case. These are three different identifiers identifying three different variables. I hope you get the point. Okay. Now, let's look at this simple example to demonstrate whether we understand the concept behind identifier or not. The first line, we're having FCE student. Can you see that? Is this one valid identifier? It contains, yeah, it's valid identifier. There is no space, no punctuation. Okay, there is nothing that makes it invalid. Look at the second one, FCE underscore student. It has an underscore. We can use underscore at the front, at the end, at the middle. You can even have successive underscores. You just mentioned that, although they can be reserved identifiers. Okay, so this one too is valid. Then FCE space student, the space makes it invalid. As we mentioned, we don't include space when you are naming identifier or a variable. Okay. Now the second row, employee underscore record, then employee record. All these two are valid identifiers. Then the last one in this row, employee space record. The space makes it invalid. And look at the third row, underscore provost FCE, and the second one, double underscore provost FCE. Just mention of underscore. Okay. Then the last one in this category is two provost FC email. The two that comes at the beginning makes it invalid. Okay. Then the last row, result 2 in capital letters, then result 2 in small letters. They are all valid identifier, although they are different identifiers. Result 2 is on its own, and the other result 2 is on its own. We made mention that C++ is case sensitive. It is seeing each and every one of them separately. Okay. Then results, comma, 2 semicolon fcet dot get. What makes this one invalid is the punctuation that it involves, the semicolon, the comma, and the dot that we are having. That makes this one invalid. I hope you get the concept. Okay. Now, the next thing we are going to talk is data type. You can't go away with data type whenever you talk on variables, because for you to work with variable, you must know the type of data that variable must hold. The values of variable are stored in the computer memory as zeros and ones, as we know. Not even variables, anything in computing is being kept in that format, zeros and ones. Perhaps we are seeing them as series of letters, digits, and what have you. But internally, it is not represented like that. Okay, the program needs to know the kind of data stored in the variable. Yeah, it is not the same to store a simple integer as it is to store a letter or a floating point number. Why? Because data types are not the same, and in many cases, they occupy different amount of memory space. You should take note of that. Okay. For example, if you take an integer data type, the amount of space it can occupy is not the same with that of floating point. Integer is the whole number, like 1, 2, 3. But the floating point are decimal. It can be 1.23, it can be 1.21, it can be 2.5, it can be 2.6789. So even the way I'm calling the numbers, you know that the way they can be, the space allocated for them in the memory will not be the same. So that's why you have to declare the data type. As you have to know the data type when you are declaring a variable. You declare it with its data type. Okay. So what are these data type? How many kinds of data type can we work with when we are working in C++? We have different kinds. The most common ones are listed here. The first one is the character. What do you mean by the character? Is just a single character like an A, like an B, like D, G, Alt, etc. Something like maybe you are great in C++. What is you are great in C++? Maybe you have an A or B or C. All these are considered to be character. Once you are mentioning just a single letter, it's considered to be a character. An example of it, or the way it is represented in C++ is CHAR, as we can see, car. Okay. Then the numerical integer, that's the whole numbers. Yeah, the whole numbers like your age. How old are you? So maybe I'm 34, for example, or I'm 56, or I'm 65, I'm 20, I'm 18, all things. You just give a whole number. Okay, so such kind of things are being represented to be of data type integer. How is it represented in C++? It's just int, as in int integer. Okay, then because you know that int is for integer, you cannot just write integer. No, the rule says that it should be int. Just leave it int. The same thing with car. You know that it's character, you just type it car. CAHR. Okay. Then the next one is the floating point. Floating point, you are referring to the real numbers, the decimal numbers, like your CGPA. Okay, it can be 2.3, 56.8, 9.1, and things like that. If you say a CGPA, it should not be more than 5 or 4, depending on the CGPA scale. And how it is represented in C++ is FLOAT, that's float. And the next one is the Boolean. Yeah, the Boolean normally represent either true or false. For example, you may ask some of the question in a form of writing a program. Do you have carryover? It's going to be either yes or no, true or false. Are you married? You say that yes or no. So such kind of things that require all this questioning that requires either yes or no, true or false, we normally use a data type called Boolean. Okay. Boolean is being represented as BOOL, called bool. Okay. Now, next thing is just the category of most of these variables. How can you use them when you are coding? We have under, if you take the character types, we have like about 4 different categories of the character type. We have the normal char that I just mentioned. We have the char 16 underscore T. We have the char 32 underscore T. We have the W char T. All this one have to do with the sizes of the characters in the computer memory. Okay. Then for integer, we have 2 different categories of the integer type. We have the signed and unsigned. If we take the integer types for sign, we have things like, they are up to like 5 different categories. Okay, we have the sign char, we have the sign short int, we have the sign int, we have the sign long int, then we have the sign long int. 5 different categories. You may decide to take any one. If you like, you can just take integer int or just sign int. Okay, then of course we have the unsigned. Under the unsigned, we have the unsigned char, we have the unsigned short int, we have the unsigned int, we have the unsigned long int. Of course, the last one is unsigned long int. The same thing with the previous one. The only difference is signed and unsigned. And the fourth one is the floating point types. This one is like 3 different categories. The normal float, then the double, which one has more decimal places than the float. Then of course the long double that has more decimal places compared to the double. Okay, you normally use the long double if you are using some computations, especially in mathematical analysis and things related to that. Okay. Um, Other ones are Boolean type, normally represented as bool, as I just mentioned. Then we have the void type, normally represented with VOID, void. Then we have the null pointer, normally represented as DECL type, then inside bracket NULLPTR. Okay. So now let's look at how variable is being declared. Let's talk about the variable declaration. Now that we know what a variable is, what are the rules governing how to declare a valid variable? We know different types of data type that we can use to declare our variable. So now, how do we declare a variable? C++ require every variable to be declared with its type for its use. Yeah, I just mentioned this in one of the slides that you must declare the data types. You must declare a variable before you can use it. This informs the compiler the size to reserved in the memory for the variable and how to interpret its value. Okay. If you declare a variable to be of data type float, you are expecting a float in that variable. If you declare it to be integer, we are not expecting you to give it a float value. If you give it a float value, you'll be having a problem because the space that is designated for it will not accommodate it, and hence you'll be having a confusion and thereby have a problem. Okay. Then the syntax to declare a new variable in C++ is straightforward. You simply write the type. And what we mean by the type here is the data type followed by the variable name. That's the name of the identifier. Here's an example for us. Let's look at the example. We have the data type followed by the name of the variable. Data type followed by the name of the variable. After data type is a space. Now, we mentioned different kinds of data type. Now, we have data type, name of variable, and the first one we have int, then school fees. What are we saying here? Int is the data type, school fees is the name of the variable or the identifier. You see that? So what are we saying? School fees is declared to be of data type integer, period. The only type of data this school fees can hold is whole number. That's all. And the next one, float employee underscore pay. Employee underscore pay is the name of the variable and is declared to be of data type float. So in essence, employee underscore pay is expected to receive the data type of type real number. That's all. Then look at the third one. We're having 2 variables declared at the same time. Int yes, semicolon, then calculate, means that you can have 2 or more of variables declared in the same line. just separated with the end of line semicolon. That's all. The first one is int yes. Yes is declared to be of data type integer, and of course your yes should be integer. If I ask you how old are you, you cannot tell me that I am 18.5. No, either you are 18 or you are 19. The next one is call grade. What is your grade in introduction to computer? So either you have A, B, C, or maybe you fail. That's all. So you cannot tell me that in my introduction to computer, I am having A, B, C. No, 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 no. The character, we are expecting only one single character. That's why you can see car, grade. You should take note of that, okay? Still on variable declaration, user can declare more than one variable of the same type. They can be declared in a single statement. Wow. They can be separated, separating their identifiers with commas, just like in this. Int, school fees, comma, int, yes. Two different variables are declared in the same line, now separated with comma. You can do that as well. You see that? Yeah. Now, let's look at this example, operating with variables. Can you see that? The first line is just a comment. We made mention of comment in one of the class, if you remember it in the previous class. Yeah, this is the inline comment, if you could remember. We made mention of two different kinds of comment. After the inline, you can remember the other one. I think you can remember it. Okay, so operating with variables is just a comment, the inline comment. Then line 2 is empty. Line 3, you can see the hash include IO stream using namespace std int main, open and close bracket, then begin and declaring variables. Just this one is to demonstrate how to declare variables. Under int, we are having a comma b. Two variables a and b are declared to be of type integer. Of course, they are valid variables. Okay. Then the third line, in the next line, sorry, line 10, you can see that int result. Result is declared to be of data type integer. So you are having three variables in essence: a, b, and result. And all of them are of data type integer. If you like, you can separate each and every one of them in a line. You can have, here we are having int result in a single line. You can have int a, then semicolon. Then the next line, int b, then semicolon. You can do it that way. If you like, all the three of them, you can have them in a single line separated with comma, just like this. Just like the way we are having the two, int a, comma, b, semicolon. You can have int a, comma, b, comma, result, then semicolon. You're having three different variables in the same line. So you have the liberty to choose whichever one you want. Okay. Now let's look at the process now. A is assigned, A is equal to 5, B is equal to 2, then the next one is A is equal to A plus 1. Wow. Okay, the result equal to A minus B. It's just normal assignment. The value of A in the first instance is 5, value of B is equal to 2. Then in line 15, if you look at it, A is equal to A plus 1. What is happening here is the first value of A was 5, now it's incremented. 1 is added to the value of that, to the that value of A. So now we have 5 plus 1, which is 6. Then our result is A minus B. The last value of A is 6, then subtract 2 from it. 6 minus 2, you'll be having what? 4. So what is left inside the result is 4. So now print out result. You can see C out result. This one will just display the value of what you are having inside the result. Then return 0, terminate the program. And of course, if you look at it, the result is 4. I hope you get it right. Okay. Now, the essence of this one is just to show some of the errors that user may likely come across with when writing the program, and not even in C++, and most of this programming language. Let me see if we can highlight most of these errors. Wow. Okay. So, operating with variables include IO string using namespace std int main, begin declaring variables. Look at the first one. I think our first error is here. Can you see it? Where my mouse pointer is pointing to A. 2A is wrong. Wow. We always start naming variable with a letter followed by 0 or more letters or digits, although you can begin with an underscore. Okay, so this one is wrong. Okay, that's one. So under the process, float B is correct, the result is correct. Look at the second one. This 2A here is also wrong. Okay. Then still, anyway, we see 2A here. This 2A is wrong. This 2A also is wrong. Still, this 2A is wrong. You see that? So 2A is not a valid variable now, not even to talk of assigning 5 to it. But B equal to 2, that one is correct. 2A equal to 2A plus 1 is wrong. Okay, result equal to 2A minus B. So what makes all this wrong is because of the 2A. Then look at the next one. Apart from this one here, you don't have the semicolon. It's missing here. Semicolon should be here. Okay, and similarly here, semicolon is missing here. Can you see that? Then if you look at it again, our C out result. Of course, this one is correct if you print out the result, but you are having error right from here. Now, on that I'm letting the program return the 0 is missing here. Return 0. 0 should be here. Okay, just like here, we're supposed to have a semicolon like this. Here we need to have the semicolon like this. And here we need to have the 0 is missing because we declare our int main and we didn't return the integer 0. Okay, so if you look at it, we are having several errors. Okay, one of the errors is in the declaration 2a, and the other one in the process. In the process, we are having 1, 2, 3, and here we are having another one. Okay, all right. So in essence, how many errors do you have? Count. Okay. Next thing is initialization of variable. C like initialization is something like data type identifier equal to initial value. That's the general form. Data type identifier equal to initial value. Just made mention of data type, made mention of identifier or variable. So the what we are added here is just equal sign and initial value. Just look at this one. Int. Int is a data type. X is the identifier or variable name. This is the equal sign that we mentioned, and this is the initial value equal to 0. And this variable initialization can be in two types. It can be either constructor initialization or uniform initialization. For constructor initialization, it's going to be something like this. Int x, then inside your bracket, you have your whatever value you want to declare. It may be 0, it can be any other thing. Okay. For uniform initialization, it's going to be something in this format. In x, then you have the curly bracket, then you have the value you want to initialize, just like in this case. Okay. How you get it right? Let's look at this simple program that demonstrates variable initialization. Okay. Wow. The first line is initialization of variable as a comment, then include IO stream using namespace std int equal to 5. Here you can see that the initial value of A is 5, then int B. Okay, this is the which initialize one of the initialization. This is the constructor and uniform initialization. This one B is 3, this one C is 2. Okay, then int result. Okay, this is the constructor and uniform initialization, and we are having them here. So now you look at it. A equal to A plus B. You already know what is A. A is 5. Okay, you already know what is B. B is 3. So A plus 5. And 5 plus 3. Of course, 5 plus 3 is 8. Then our result is assigned to A minus 6. Our last value of A is 8. So it's going to be 8 minus C. The value of C is 2, which is going to be 6. So the result will be having 6. Now C out result will print the result and the value will be 6, just like in this case. Can you see that? Wow. Hope you get it right. Alright, next thing is introduction to string. As I mentioned at the beginning that when you talk of variable, you can go away with string. String variables are able to store sequences of characters such as weights or sentence. Yeah, whenever you want to store sequence of character that is more than one character, you have to use what we call the string variable. You want to store something like your name, maybe having some bulky letters that form your name, not just a single letter, or you want to print a sentence, okay, something that contains many characters, then you need to use what we call the string. the program needs to include the header where the type is defined within the standard library. The include string is declared before using the string. You should take note. At the beginning of the program, normally you have the hash include, then string should be included. Okay, you don't just use string like that. You must declare it before using it. How do you declare it? You have to include the standard library. Okay, now let's look at this simple example that demonstrates the use of the string. The first line is my first string as a comment, then the hash include IO string, hash include string. Can you see that? Then using namespace std. Are we there? Using namespace std. Now, this is what we are talking about. Yeah, include string. Okay, this is the header that is included. Now, int main. This is our beginning string. Then here the variable is string. And sorry, the data type here is string. And the name of the variable is my string. This is the name of the variable, my string. Okay, so here my string is assigned to this statement. You can see that it's enclosed within the double quotation. This is a string because it's not just a single letter, that's why it's enclosed within the double quotation. Okay, so all these things now will be assigned inside this variable, my string. So see out my string. Whenever you say print my string, it will print this one. Okay, that is why after you run this program, you will have this as the output. Hope you get it right. Okay. The next thing is constants. What are constants? Constants are expression that has fixed value. You may think of constant like something like pi, for example. Pi always is 22/7 or 3.141592. Okay, or maybe physicians normally say acceleration due to gravity, things like that. Anything that remains fixed. For example, I say your age is not fixed. It's always change, okay? That one varies, okay? So things like that that has fixed value are referred to as constant. How do you declare constant? You normally have the constant keyword followed by the data type, then the name of the variable, then the equal sign, then the literal. Look at this one now. We have the constant, then the data type double, then the name of the variable pi, then the equal sign, okay, then the literals here. This is the literals. You see that? The same thing with this one. Const car equal to single quotation backward slash t single quotation semicolon. Okay, all whenever you call pi or you use pi in the program, it's as good as you are using this one. Similarly, whenever you use something like this, it's as good as you are using this one. Okay, basically that's the importance of it. Now, let's look at a simple program that demonstrates the use of this constant. Maybe we can have a better understanding of what constants are. We look at it. We have in the first line include IO stream, then using namespace std. Can you see that? Then we have the constant declaration. This is where it's gone. We have the const keyword. We have the data type double. We have the name of the variable pi. We have our equal sign. Then we have our literals. Can you see that? Same thing here. Constant data type, a variable new line, then it's assigned to this. Okay. So whenever you call pi, you are calling this. Whenever you call new line, you are referring to this. Okay, so you look at it. Int main. Can you see that? Begin here, double r equal to 5.0. Okay, this one is a comment. It's supposed to be from here already. This one's supposed to be at the beginning here. This like this. It's just a comment radius. Okay, then double cycle. Now you can see cycle equals to 2 times pi times r. You see that? 2 times pi times r, then our C out equal to cycle. So we look at it. 2 times pi is this 3.14159 times r, our r is 5.0. It's already declared and initialized at the same time. So if you multiply, you have 31.4159 here. The output will be given 31.419. Then this one will move to the new line. That's all. Hope we get it right. Okay. Apart from the constant, there is what we call literals. Literals are used to express particular values within the source code of a program. To give specific values to variables or to express messages we want our programs to print out when we write. For example, a equal to 5. The 5 is the literal constant. Or if I say x equal to 5.0. That 5.0 is literal constant. Okay, you can have character constant, you can have string, you can have character, literal and string literal, just like the way we are having literal constant, we have also character and string literal. You just mentioned that character can be just a single letter like A, like B, like C, and things like that. So if you're having something like this, look at this one, Z, just a single letter. Notice that it's enclosed within the single quotation here. Okay. Look at this letter P, is enclosed within the single quotation because it's only one. So all these are character letters. If it is string letters, it must be enclosed within the double quotation like this. That's why it is called string letters. Look at this other one. How do you do? Okay, it's more than one character. That's why it's enclosed within this double quotation. You should take note of that. Okay. Wow. And next one is the preprocessor's definition, normally represented as the hash sign then defined. It's another mechanism to name a constant value. It's normally used. Another mechanism to name constant value is the use of preprocessor definition in the following form. This is the general form. We have the hash sign, then define, then the identifier, then replacement. Or after each one of them, there is space in between. After this, the directive, any occurrence of identifier in the code like this identifier is interpreted as a replacement. That's a replacement here, whatever I have in here. That's any sequence of characters. Note that the hash defined lines are preprocessor directives and as such not require the semicolon at the end. Wow. Let's look at how it's represented in the program. Now, this program just demonstrates the preprocessor definition. If you look at this, it's the same thing with the previous one that we mentioned, that we demonstrated using constant. Okay, so the constant that is changed now using the preprocessor's definition, because it's another way of doing it. Okay, so we are having to include this and that using namespace std. Now look at it. We have the hash sign defined, then we have the pi. You see, this is the replacement. So this one now will be replaced with this. Look at this one, define, new line, and this is the replacement. You see that? Wow. So now int main double r equal to 5.0. This one is a comment. It's referring to this one. Okay. Then double cycle. Cycle is declared to be of type double. Then our cycle is equal to 2 times pi times r. You see that? Then here 2 times pi. Pi here, set of pi, it will just work with the replacement here. That's all. Then times r is 5.0. Then when we compile, when you compute this one, is 2 times 3.14159 times 5.0, the same thing the previous one. We'll be having something like this, and the result will be kept inside cycle variable. Let's see out new line, then to move to the new line. That's all. Okay, and with this, we come to the end of today's class. Thank you so much for listening.